Now, the next topic was, you must have a little idea about trisaccharides, tetrasaccharides, and pentasaccharides. At least one example. One such example is raffinose. Raffinose is a trisaccharide. Remember, these trisaccharide, tetrasaccharide, pentasaccharide, these are all, they are part of dietary fibers. Means we cannot digest them. We cannot digest them. We do not have enzymes to digest more than disaccharide. But we can digest polysaccharide. How come? Because our enzymes are bond specific. Because our enzymes are bond specific. Mostly these trisaccharide, tetrasaccharide and pentasaccharide we cannot digest. So they actually comprise a good part, a good portion of our daily vegetable intake. All leafy vegetables, they contains these trisaccharides, tetrasaccharides and pentasaccharides. So three examples: raffinose, stachyose and verbascose. Their structure is very easy to remember. Their structure is very easy to remember. 2 points you must remember. One, we cannot digest them, and they make a part of dietary fiber present in leafy vegetables. That's all. Now, apart from this, one of them has got little more function that I will explain. Now, this one is a structure. Can you tell me what is this structure? Yesterday I drew some structure. Do you find any of them in this structure? What is this? What is this sugar? Which sugar is this? Glucose. And this one? Galactose. And this one? Fructose. So fructose plus glucose means what? Sucrose. To sucrose, if you add one galactose, it becomes raffinose. Clear? Sucrose plus one galactose becomes raffinose. Next, stachyose, tetrasaccharide. Sucrose, galactose, galactose. One more galactose, it becomes stachyose. Verbascose, V means Roman 5, pentasaccharide. Sucrose, galactose, galactose, galactose. Easy? Huh? So now you can describe the structure also. Correct? Fine. Linkage, what is the linkage here? All are 1,6. Alpha 1,6. And this one is beta 1,2. Now, this particular compound, verbascose, has got a special function. It can be used as an artificial sweetener. Not artificial, but natural, but non-carbohydrate means non-sucrose sweetener. Okay, fine. Now we come to this, some derivatives of sugar. Some derivatives of sugar. Sugar is an alcohol, aldehyde or ketone. Correct? If you oxidize the sugar, what will happen? Which functional group will be oxidized first? Aldehyde or alcohol? Aldehyde. So aldehyde will become acid. So what will you call when glucose is oxidized by mild oxidizing agent? Huh? Gluconic acid. Correct? Gluconic acid. Can we oxidize this? Yes. This is mild oxidizing agent, this is strong oxidizing agent. So it will become correct. These acids are called onic acids and these are called saccharic acid, means glucaric, saccaric, saccaronic, saccaric. If it is glucose, it is correct. Now we need to oxidize this one alone. Can we do it? Anyone? This happens inside our body, inside the cell, by uronic acid pathway. The enzyme holds the C1 and disallow the oxidation of the C1. But in presence of enzyme, oxidizing agent, this gets oxidized. So this becomes glucuronic acid. Correct? Like this. So this glucuronic acid participates in a lot of compounds in our body as conjugates. Okay, that we will see later. Then if we reduce it, it becomes alcohol. All aldehyde ketone will be converted to alcohol. So we will call it what? We will call it corresponding alcohol. Correct? These alcohols has got use in the medicine. Correct? It is used to increase the intracranial pressure. Dulcitol, glucinol, these are formed in uncontrolled diabetes mellitus. In the eye as a part of polyol pathway, as a part of polyol pathway. Correct? So the person suffering from diabetes mellitus will produce more and more these alcohols and will get trapped in the eyeball. Will increase the pressure inside the eyeball, intraocular pressure will be increased and that will lead to damage of retina and lead to blindness, retinopathy. Now, they can also be conjugated with amino group forming amino sugar. Amino group can also again be conjugated with acetyl group to form N-acetyl amino sugar. All these compounds are generated to impart charge in the molecule. Why do we need to conjugate these sugars? Because sugars are chargeless. Chargeless means worthless. No charge, no worth. So converting it to charged particle, you need to add some addendum from outside. Say for example, in the first step of glycolysis, what is the goal we achieve in the first step of glycolysis? We trap the glucose inside the cell. We do not allow the glucose to go out again. This door is open. You can come inside and go outside as well. Similarly, the glucose transporter can be used in the both reaction. Fine. But if it happens so, then how come the cell will get glucose? If I am very lenient, very loose in the class, then what will happen? You will come inside and go outside. You don't need Mentos. But if I am strict, then you have to use Mentos ka brain. You know Mentos ka brain? No. Ask your friend, they will tell you. So, the person, the moment you come inside, I see you, you are trapped. The same thing happens when phosphate group is added to a glucose or a N-acetyl group is added to a glucose, it becomes negatively charged. So it cannot come out of the cell, right? It gets trapped. Now, what are the use of this acetyl sugar, acetyl amino sugar, all these things? এগুলি আর পড়াচ্ছি না, these are এখন এগুলি আসে না খুব একটা, এগুলি পড়ানোর দরকার নেই। আচ্ছা, এখানে অল্প একটু just slightly I will touch starch, structure of starch slightly, very short way. It doesn't come nowadays. Okay. Starch, by definition, it is a storage form of carbohydrate in plants. Are we plants? No. So we don't need to worry about starch. Correct? So starch has two components, amylose and amylopectin. Starch has two components, amylose and amylopectin. What is amylose and what is amylopectin? That can be explained by a table. Very few people can reach out to that height. Huh? So enjoy the rarity. Amylose is a water soluble part of the starch. Is there anyone who has seen starch in the classroom? No one has seen starch. Yes, you have seen starch. Where? Huh? Something like white powder. Used for? Corn starch is different. That's a corn starch, same. Okay, go ahead. Corn starch, okay, fine. So used for what? Thickening of what? Anyone else who has seen starch? ভাত দেখিস নি? আচ্ছা, কে ভাত খায়নি বা ভাত দেখেনি এখানে? ভাতের ফ্যান আর ভাত দুটোর মধ্যে তফাৎ কি? The insoluble part is amylopectin, what we eat. The soluble part we throw away, which counts around 'Correct? So we purchase 100 rupees equivalent of rice and we throw away 25 rupees. What will happen? What will go wrong if we eat the bran along with the butter fan, along with that, the starch of the rice? Nothing will happen. Starch is easier, this rice bran is actually easier to digest. You know, small kids and old people, they are given this boiled, overboiled rice, siddho bhat যেটাকে বলা হয়, along with the starch. You know, because it is easier to digest. So we throw away the easier part and keep the difficult part to digest. Right? And this is more costly than this one. You know? When you age the rice, this portion is deleted by bacteria, eaten up. After aging, 1 year or so, the rice completely becomes amylopectin, and hardly you get in aged rice, hardly you get any rice bran. No starchy part. Yeah? Anyway, then it is water soluble. When I say iodine solution, have you seen iodine ever? Iodine? Is there anyone who has seen iodine? No one. You didn't have any wet lab in the chemistry in school? No. You had. Did you see iodine? Brown color. Very good. Actually, thick brown ki? Reddish brown, ওটাকে কি বলা হয়? পার্পল বলা হয়, খুব ডার্ক পার্পল কালার হয়, দেখে মনে হয় ব্রাউন কিন্তু অ্যাকচুয়ালি ডার্ক পার্পল। হ্যাঁ, তো আয়োডিন জলের মধ্যে গলে না, it is sparingly soluble. We cannot prepare aqueous solution of iodine. Then how you will prepare iodine solution? Testing is later. Iodine cannot be dissolved in water. It is always dissolved with so what we use as solution of iodine is nothing but Ki3. Correct? So when you add this iodine, these iodine molecules get trapped in this helix. And this particular association is called a type of physical reaction. A type of physical reaction. No chemical reaction, no exchange of atoms or molecules. This physical reaction produces deep blue color. Deep blue color. Correct? The color of his shirt, base color of his shirt. Yes. Like this, deep blue color it will be. Right? When you boil it, heat the solution, the color will disappear. Why? When you heat the solution, this spring-like structure will extend. and iodines will be released. Right? So no color. When you cool it down again, the color will reappear. So this is a particular, very important reaction for identifying starch. Now how do you know a food is adulterated with starch? Rasgulla, a well-known sweet in our part of world. So rasgulla is often adulterated with maida, flour. When you add a drop of iodine on the rasgulla, if it turns blue, that means they have added not chana, maida into it. Okay? By this you can test the purity. But anyway, adding maida is not harmful. Is it not harmful for our body? So you cannot blame them that you are adding something which is very harmful. Only thing you can do, you can ask for to reduce the price. Okay, why you are taking 20 rupees per piece? You take 10 rupees because you are adding maida. So like that. So similarly, the same test is done to find out this thing. Amylopectin structure, this particular structure you must understand. There are two ends. One, this. These are called a molecule, amylopectin molecule will have only one reducing end and rest all non-reducing end. Right? So this theoretically this should answer Benedict test. But since there are 100 of glucose molecule for one reducing end, the number of participating reducing end is greatly decreased. So the color formed or whatever amount of reduction happens is very less compared to free glucose, free fructose, free galactose or maltose. So they do not answer Benedict test. Starch do not answer Benedict test, neither amylose nor amylopectin, right? Because they have very less number of reducing ends, right? What else? The linkages. Here we have only one type of linkage. Alpha 1,4 glycosidic linkage. Here we have alpha 1,4 plus at the joints or branch points we have alpha 1,6 glycosidic linkage. So two linkages here, here only one type of linkage. Now we come to the animal part. This is the storage form of carbohydrate in animals. Storage organs are liver, kidney, muscle, brain, almost all tissues in small amount. But the majority of the glycogen are stored in two organs. One is liver, another is muscle. Correct? Among them, the muscle glycogen is called selfish glycogen. Selfish means who thinks about only himself or herself and no one else. That means when you are dying out of hypoglycemia, the muscle glycogen will not contribute to blood glucose level. That's why it is called selfish glycogen. But the liver glycogen will donate its glycogen, break down the glycogen and donate the glucose to the bloodstream for your survival between two meals. Suppose at around 8:30 you had your breakfast and again 1 o'clock or 2 o'clock you will have your lunch. In between you do not suffer from hypoglycemia. Why? Because your liver will supply the blood glucose and maintain the blood glucose level at a particular level so that you do not faint. Right? So it is possible due to the benevolence of the liver glycogen. That's all. But your muscle glycogen will not be utilized. Fine. Now this is, it is like this. It is highly branched. Reaction with iodine produces red color. Now, let me explain why the structure of glycogen is like that. Remember, in nature, our structure is actually the requirement for a particular function. Every structure has its own function. Every structure, any protein, any carbohydrate, any lipid, whatever it is. Similarly, this glycogen has got this structure because of some reason. The linkages are same, alpha 1,4 and alpha 1,6 at the branch points. Same like amylopectin, but more branched. The first point is, it has many non-reducing ends per molecule. Suppose there are 100 glucose molecules in a glycogen molecule. If we want to keep 100 glucose molecule in the solution, then what will happen? The solution is boundaried by cell membrane. So the 100 glucose molecule will impart a huge amount of osmotic pressure on the membrane. So it will draw more water. So what will happen? Our liver will swell up. But that never happens. Right? So why? Because we make them a polymer and reduce the number of reducing end. So now if you form one glycogen molecule containing 100 molecules of glucose, you have osmotic pressure exerted 1/100th of having individual glucose molecules. Am I clear? 100টা গ্লুকোজ মলিকুল যতটা অসমোটিক প্রেসার তৈরি করে, একটা গ্লাইকোজেন মলিকুল তার 1% অসমোটিক প্রেসার প্রডিউস করে। Correct? তাহলে by reducing the number of reducing end, we reduce the osmotic pressure when we are going to store the same amount of carbohydrate in the body. Number one. Number two, when we are in need of energy, we need to release energy, we need to produce more and more glucose. Suppose these 5 fingers and you put a chopper here, what will happen? You will have 5 pieces. If you have only 1 finger, you will have only 1 piece. So if you have more number of non-reducing end, you produce more number of glucose units per unit time when in need. Clear? So these are the 2 factors which are utilized by this particular structure of glycogen in the body. Number 1, reduction of effective Number one, reduction of effective osmotic pressure. Not feeling well. Reduction of effective osmotic pressure. And number two, availability of more non-reducing end. Availability of more non-reducing end per molecule for breakdown of glycogen. For breakdown of glycogen. These 2 points. Okay? Clear? Now, when it comes to polysaccharide, we cannot escape from dietary fiber. Polysaccharides are of many types, which some we can digest, some we cannot digest. Achha, did you ever eaten glycogen? Eat glycogen? Is there anyone who ate glycogen ever? Anyone? এখানে কেউ আছো যে গ্লাইকোজেন খেয়েছো চিবিয়ে চিবিয়ে? কেউ আছে গ্লাইকোজেন খেয়েছে? এমন কেউ আছে যে মাছ মাংস খায়নি? নেই? সবাই গ্লাইকোজেন খেয়েছে। ভেজিটেরিয়ান, হ্যাঁ? Vegetarian, you demand that you have not taken glycogen ever. Fine. Did you ever take curd? How do you produce curd? Did you ever take bread? Bread. How do you produce bread? What do you add to the maida so that it becomes bread? Yeast. Now, recall your higher secondary knowledge. Inside of yeast, there is glycogen. So you have taken glycogen. Sit down. Correct? So glycogen is present in any muscle, any form of muscle. If you have taken muscle, you have taken glycogen. Right? Very good. Now, dietary fiber is something which we cannot digest, but it is very, very important for our diet. Why? Because of many reasons. Number one, write down. Importance or significance of dietary fiber in diet. কি হলো? হ্যাঁ? কি বলছে? क्या बोले? कुछ नहीं है. Number one, dietary fiber add bulk to stool. Dietary fiber add bulk to stool and prevent constipation. Okay. Number two, dietary fiber add bulk to stool, B-U-L-K, bulk to stool and prevent constipation. Number two, dietary fiber absorbs water. Absorbs water in the gut to increase the dilution of any poisonous substance present in the food. To increase dilution of any poisonous substance present in the food. If your food is full of dietary fibers, then the effective amount of poison in the food will be reduced due to effective dilution. I'll give you an example. Suppose you add 1 drop of poison in 1 cup of tea, and in another case 1 drop of poison in a bucket of tea. What will happen? If you take 1 cup of tea and 1 cup from the bucket, more possibility that you will die in which case? 1 cup alone. So these dietary fibers, what they do, they absorb water. Okay, draws water inside. So in the gut, the water is soaked and gets swollen up, correct? And inside that water, because that capillary space, those molecules, they get diluted, more dilution. So our cells, means our mucosal cells, they absorb or they absorb any substance based on their effective concentration, not absolute concentration, but effective concentration. Absolute concentration is something different. Effective concentration means in comparison with other molecules. Right? Suppose your name is Oishwajarai. Suppose. So if there are many Oishwajarais, then it is very difficult to find out you. But there is only one Oishwajarai in the classroom. It's very easy. Correct? So there are many molecules. So your concentration becomes 1 by those many molecules. That is your effective concentration. But your absolute concentration is same. You are 1. Clear? So they increase the dilution and decrease the effective concentration of the poisonous molecule. So they get absorbed in less quantity and less possibility that you will die. Fine. Next, presence of dietary fiber reduces cholesterol absorption or fat absorption. Reduces fat absorption. The source of dietary fiber is mostly vegetables. These vegetables contain phytic acids. Phyto means plant, acid of plant source. So these phytic acids, unless the dietary fibers are very purified ones, nowadays many dietary fibers are available in the market which are purified. Actually, those should not be taken. You should take rather more and more vegetables than taking those purified fibers, because the purified fibers lack these phytic acids. Correct? Now these dietary fibers, they contain phytic acid. This phytic acid, they combine with these fatty acids and they decrease the absorption of fat from the gut. So you can reduce the risk of coronary artery disease by reducing the absorption of fat from the gut. Clear? What else? Presence of dietary fiber in the food reduces risk of colon cancer. One of the most major cause of colon cancer is the precipitation or remittance of heavy metals in the colon. So lead, cadmium, etc., etc. And where do you find them? Mostly a drink called beer. In Western country, people, they save water, drink beer. Right? So they suffer, and moreover, their diet contains more about meat and less vegetables. Right? Because they do not grow those vegetables more over there. They only hunt the animal and kill the animal and have the meat and have beer. That's all. Don't need water. Clear? So these people, they suffer more from colon cancer. Whereas in our place, it is very less occurrence of colon cancer. Why? Because our normal diet contains a lot of vegetables. Right? That actually saves us from the colon cancer, occurrence of colon cancer. Okay? Drink water, please. Please drink water. এটা একটু পড়াবো, তারপরে এটা পড়াবো। আচ্ছা, yesterday one of you have pointed out about mutar rotation, হ্যাঁ, small topic. পড়াবো না এটা পড়াবো? Which one you prefer? Choice is yours. বল কোনটা পড়াবো? চলে না একটু ভালো জল, কাল থেকে পড়ে আছি। কোনটা পড়ি বল? এই কালো জামা, দাঁড়া। বাংলা বুঝিস? বাংলা বুঝিস? ঘুম হলো? ক্লাসে মোবাইল দেখা বন্ধ কর। দ্বিতীয়বার দেখলে বুঝিস? তো চালাকি করে লাভ নেই, চালাকি করে কোনো লাভ নেই। পিছনে বসে মোবাইল দেখো, দু একদিন বারণ করবো, তারপরে বারণ করবো না, গোল্লাই যাও, শুধুই যাও। পরে কান্নাকাটি করাচ্ছে কি, এখন তো চেষ্টা করো। The process by which a molecule in solution gets converted to its alpha or beta isoform is called mutarotation. Suppose you start with alpha form, after some time it will be converted to some amount of beta form. You start with 10% beta form, after some time it will be converted to alpha form. So what happened? The experiment was like this. They prepared alpha D sugar, glucose and beta D glucose in 2 test tube. Correct? Freshly prepared. How do you produce alpha? When you crystallize glucose from aqueous solution. And how do you produce beta? When you crystallize glucose from pyridine. Pyridine. Like this, they have prepared alpha and beta form of glucose and they measured the specific rotation. It became how much? Around plus 112. And beta became একটু এগুলি হতে পারে, খেয়াল নেই, মনে পড়ছে না। আচ্ছা যাক, 18 পয়েন্ট সামথিং or 19 or এটা হচ্ছে 112 or 111.8 সামথিং was 112, ওটাকে 18 ধরে নাও। যাও, now after some time, say for around 4 hours, they see that both the solution has become now plus 52.5. কালকে বোধহয় আমি 56 লিখেছিলাম, একটু গন্ডগোল হয়েছে। 52.5 degree. Correct? They repeated the same experiment again and again, day after day, and they found the same result. So they couldn't understand what is happening. Okay? Then they isolated in the pure form and they found that this contains alpha and beta. Alpha is around 36%, beta is around 63%, and open chain is around 1%. 36, 63 and 1% open chain, Fischer form. So open chain is the intermediate through which it gets converted from alpha to beta or beta to alpha. Right? This process of interconversion is called mutarotation. Clear? So when mutarotation comes, you can give this example and you can draw this graph. correct? So this is স্পেসিফিক কোয়েশ্চেন থিটা বলা হয় আর এটাকে টাইমের এগেইনস্টে পুট করা হয়। এটা গ্রাফ দিতে পারো। এবার একটা ছোট্ট কোশ্চেন, আরেকটা ছোট্ট কোনো স্মল কোশ্চেন, লেট মি আনসার। দিস ওয়ান ইজ what is called invert sugar? What is called invert sugar? Invert sugar is called you take a pure sucrose solution and then let it open, let it stay like that. Okay, leave it. After some time, you see its specific equation is changing. Specific equation is changing. It was positive, then it become negative. It was positive around 66. Initially, it was around 66 degree. Later, it became around minus 42. How come? Because sucrose is broken down by this one, about 52.5 glucose, and fructose is around 92. Add up, you get around 40. Correct? So which is produced by hydrolysis, aerial oxidation, or by action of yeast, or by action of bacteria, whatever it is, or you add enzyme, sucrase, whatever it is. It produces. So they call, actually sucrose is not called invert sugar. It is a product which is formed by hydrolysis of sucrose, which is actually equimolar mixture of glucose and fructose. It's called invert sugar. Fine. What else? Any other question from this short question from this part? Then I will stop here, because tomorrow we will study this one, glycosaminoglycan part. Just read and come. Glycogen is almost done. So just read and come around glycosaminoglycan. Okay.